Expand using binomial theorem. Now, we know we can expand this by repeating this pattern and multiplying it by itself 5 times over, right? Blah, 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 blah. That's going to take a lot of work on our part. Another way we can do this is following Pascal's triangle. Now, we talked about in a previous video, if we're to the power of 5, what that actually means is we're on the 6th row in the triangle. So we've gone about drawing these rows. Okay, here's the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. The reason being is because this would be our binomial. This is a plus b. There are 2 terms here, and that's to the power of 1. Where we have a trinomial, well, that makes sense. When we have a quadratic type equation, we square it, we end up with a trinomial, right? So if there's going to be to the power of 2, 3, 4, if we're to the power of 5, we're going to have 6 terms in it. So we're going to be talking about this row here. Okay, this would be 3. This would be 4. This would be to the power of 5. You know, they use for computers those little hats for exponents. That's the idea. Okay. So what we do know is we're going to be in the 6th row, and our coefficients are going to be multiplied by these values. Okay. Now, the other thing we do have to talk about is the way we're going to set up our variables. Now, the way our variables work, it depends completely on the number of terms. Because there are 5 terms here, or the number of terms isn't important, but the power. The power is extremely important because what we're going to be doing is putting our a and b values to those powers. So in this case, we actually have a subtraction sign, and the subtraction is going to be important too because that's going to rotate our operations. Between each of these, we're going to go kind of a minus, plus, minus, plus, minus. Okay, where in if it was just positive, everything would be positive in between. Okay, so that's just an idea of where to put the operations. Our a value, the way this will be set up because it's to the power of 5, I'm going to write it all out and then we're going to kind of make sense of it after, is we're actually going to have a to the 5th and we're going to have b to the 0. Okay, that would be our first term, essentially this term here. Okay, and again, we're going to be multiplying by that coefficient, which is in Pascal's triangle 1. Well, technically, it's going to be then subtract, because we said we'd be subtraction 5. We take this coefficient 5, and that's going to be a 4. So we drop the exponent here of the 4, but we increase the exponent of our second term b to 1. Okay, then we're going to have a plus sign. Well, the next number in Pascal's triangle is a 10. So we multiply that by 10. We're going to have a to what power?
3.
3. And b to what power?
2.
2. Good. I actually want to complete this, so I'm just going to move it down so we have a little bit of room. Okay. Down here. And we'll zoom in a bit. We got to figure out this pattern here. Okay, what's the next term in Pascal's triangle? We have a what?
Minus 10.
Minus value of 10. We're going to have a to what power?
2.
Yeah, that's right. We decrease b to the
4.
Good. What's the next number?
Plus 5.
Yeah, positive 5. Remember, the only reason it's rotating negative to positive is because we have a negative value in there. Otherwise, it'd be positive.
Would it be 3, sorry?
Oh, yeah, sorry. That would be 3. Good. Next one will be a to what?
E to 1.
Yeah, b to
4.
Yeah. And then finally, what's our last one going to be?
A, well, minus 1.
Minus 1. A.
0.
0.
To be 5.
5. Exactly. So we actually have our a and b values right here. We can plug them into this. Okay. Now, once we learn a formula that's actually extremely fast to use, we just have to set it up first. Our terms were 2x minus 3y. Is that correct?
Yeah.
Let's double check. Yeah. Okay. So this being our a, this being our b. Well, 1 times this is not going to make a difference, right? B to the power of 0 is going to be just the number 1. So we already know this is going to be 1 times b to the 0 is 1. All we really got to do is put this value to the 5th power for the first one. Okay, well, what's 2 to the power of 5? Do you know off the top of your head?
25. No.
I think it's 32 in that
32.
case. Let's take a calculator out so we can just double check everything. 2 to the 5th, 32. Perfect. And of course, our variable is going to be to what power?
1. No, 5.
5. That's right. Okay. That takes care of our first term. Now our second term. We're going to be multiplying by negative 5. Okay, because that's the number in Pascal's triangle. A to the 4. Well, we got to put 2 to the power of 4. 2 to the power of 4 is going to be 16. Okay. x4. But in this case, we're actually also multiplying by b to the power of 1. Well, that's 3y. So then also multiplied by 3y. Okay? And we're going to continue this pattern as we go through this. That's the second one. Third one, we're going to be adding 10. A to the power of 3. Well, 2 to the power of 3 is 2, 4, 8.
Yeah.
8x cubed. Right? That's the power of 3. B squared. Well, we're going to have b squared, which is going to give us 9y squared. Okay? Next one along here, minus 10. Okay? And as you see, this kind of gets crowded as we go through it. A squared is going to be 4x squared. 3 cubed is going to be 27y cubed. Okay? I think I could squeeze a little more space in here. I started kind of large, but we're going to move it over a little. Next terms, plus 5 because Pascal's triangle. What's our A?
2x.
Yeah. And so the fourth here, you're going to need a calculator for that one.
81.
Okay. 81y4. And then we're going to sneak in the last one here. We know we're going to have the number 1. A to the 0 is going to be what?
0.
Not 0. Any exponent to the power of 0 is 1. Good. So that's going to be 1. And our b to the 5th. We know it's going to be y to the 5th. 243. Okay. So now what we're going to do is we're going to actually take each of these values and just simplify them. So there are 5 major values to simplify. Okay? So 1 times 1 times 32x5 is obviously 32x5. Right? We multiply all of our coefficients. So 5, 16, 3. You can do that on a calculator for us? 5, 16, and 3.
240.
240. Yeah. And then we just put the variables beside each other. X4, y. Next one, multiply the coefficients again. 10, 8, and 9. That's going to be 80 times 9. 720?
720.
Yeah, 720. X cubed, y squared. Okay. Next one, we're going to be subtracting 10 times 4 times 27.
1080.
1080. And that's going to be x squared, y cubed. Next one's going to be positive, and then we have 5 by 2 by 81, so 10 by 810. xy4. Is that right?
Yeah.
And minus, obviously, it's just a lesser term. 2, 4, 3, y5. Now, this may not seem like it was faster than the other way, but once you get the hang of this patterning, it does become much quicker than actually deciding to go through the distributing this long process here. Okay? Does that make sense?
Yeah.
So that would be the binomial theorem in order of solving this. So you got to know Pascal's triangle. You got to be able to set that up.
Okay.
Okay?